Um, Welcome again. So we have gone through a few chapters that's setting up the environment and learning Cairo language. So through the Cairo language, that one took longer. That's 1 hour 41 minutes, maybe 1 hour 40 minutes. I don't know. But now we are looking to the next chapter, that is writing smart contracts. And the first portion of it, we are going to just cover a small portion that's defining the contract logic. And what is this? So before we just jump into the writing a smart contract, I want us to quickly learn how the contract, how a contract looks like just a simple view. So this is what we have. So clearly define the logic of your contract. So the main module of Cairo contract is decorated with the hash Starknet contract macro. This marks the entry point of your contract. As I said that when we were starting the learning Cairo language, we said main function is the main entry point of your lib.cairo file. But now if you are writing a contract, then hash Starknet contract will be the main entry point of your contract. So remember that. This marks the entry point of your contract. The main storage struct is decorated with hash storage. So let's say this is our sample contract. I don't know, this is our day 5 volt contract. We need to mark it with the Starknet contract. Then we have the storage macro that marks the storage struct. And remember, we can only have a single storage struct in our entire application or in our entire contract, and it's always been decorated with the storage. Then we have the main event enum is decorated with the hash event. So that is this the main event enum. You only have one for your contract, so remember to have enum there. It has to be decorated with the event and the derived drop and Starknet event. And also, while the rest of the structs for the events are only decorated with the hash Starknet drop, yeah, just that macro there for each of the consequent events. A few things missing here, that's the use of store. So without further ado, why can't I walk you through the code itself? So I'll walk right into the where we are doing our tutorials. That's our first project, but now I'm going to sort of create our first contract. So congratulations for reaching this part so far. So without further ado, let's do the defining the contract interface or how the contract looks like. Then we are going to write the contract. So for this case, I'm not going to use scab new to initialize our project. I'm going to use a SendForge init, and I'm going to do first contract like this. Is this the first contract or just the sort of stuff? Now that we have like this, I'm going to cd first contract like that and code dot. Okay, it has done its stuff. So let me just do code dot like that. So what do we have here? Let me sort of close this. So whenever you are using a SendForge, as I said, a SendForge is also very critical. Let's see what it has given us. It has given us the source folder, the test folder, gitignore, of course, with the target, and also scap toml file. But in our scap toml file, it has included very critical things. The first one is a SendForge standard, dependency, and also Starknet. So Starknet is the one that we're going to use to write our contract, of course. And the SendForge standard is going to help us very much in testing our contract before we even send it to the local devnet or maybe testnet, Goeli, or Spolia. So then we also have the target Starknet contract. The target means here is whatever you are going to build during like scab build, remember to produce Casim also. So whenever we do sort of, let me just run that command here like that. So if I do that, it should also be able to the Cairo assembly code, that is this one here, compiled contract class. It should also be able to generate this stuff here. Is it this one? I believe, yeah, it should be able to generate this one whenever you are running. And also besides Kasim, we can also add here, is it Sierra? So if I say Sierra true, so that's why I said the script.toml file is also very critical. Okay, let me just go to dev. I don't see where it did build that one. I think it's being built by default. That's the Sierra program under the contract class. Anyway, we'll get to learn more about that one. But so we have the script.toml file, very critical. We have the source folder. I'll get back to the tests in a moment. So as I said, there are some things that I'd missed to capture here, but I think I will add them before I publish this resource. That is something like Starknet interface. Remember, we did traits in our Cairo language, but now how do we use traits here? Whenever you have a trait that you want it to be associated with your contract, you have to decorate it with Starknet interface. So this one will also take care of the trait functions and expose them well as contract stuff. Then we also have the Starknet contract, and our contract here is called Hello Starknet. So that's how your contract is being called. We have the storage macro that is over the so-called storage struct, and also we have another implementation of this Hello Starknet interface, and you can see the naming case here. It's starting with iHello, meaning it's an interface. That's why it starts there, and now you can be able to see the generics being used very much in this case. So in this case, generics are used to be able to track the T contract state out so that you can just move your interfaces maybe into a different file, import them, and just keep your work clean using the modular system. That's using different modules. Maybe create an interfaces.cairo file, maybe create structs.cairo file, types.cairo, utils.cairo. So I'll talk more about those ones. Some other critical part here is the hash external v0. So if I were to remove this one, for example, like this, it means all these functions are going to be private and can only be accessed by the contract itself. But if I want them to be public and accessed publicly outside, I need to use the external v0 macro there. So these are part of the things that you need to look at when you're writing your contract. And the rest of them are the events. So I'm going to copy that one and paste it here. And events can only be used under, so I'm getting the contract address error there. I need to import it. So I can just say use Starknet. Starknet, I want to use the contract address like that. So that's where I'll talk more about the imports here. So I want to say the event I want to run here, it's not event one, but rather I want to call this increased. So that's the event. Actually, I need to rename this to increased maybe. And the next event I want is decreased. So I can quickly do that and do a comma there. And here in the case, instead of doing like that, I maybe say by which number. Okay, let's say amount, that's the thing. And the amount here in this case is a file 252. So it can be the same stuff, increased and decreased, because they're not much different. So I can literally say that, and whenever I increase my balance, I just say self.emit. What I want to emit is increased with amount to amount, like that. That's how you emit events. And I'm getting an error here. Portraits, multiple implementations. So maybe this can be the problem, but let me sort of do a decreased stuff there. I copy this one to decreased. Is that gone? Oh, right. Yeah, so I can emit the increased and also emit the decreased. uh, I'm just increasing. Oh, I'm not. Okay. So meaning this event is just null and void, but that's how you do your events. So that's the first event, and this event will be emitted whenever this function is called and whenever this assert passes. If the assert is true or like it does not panic or fail, then the rest of the stuff will be called. This is assert here. This is part of contract security. That's how you do it. You have to assert who is calling this function. Does the user calling this function meet the requirements? Yes or no? That's part of it. So we have Starknet interface, Starknet contract, storage, and event. There's one more thing that is not here. That is, I wanted to store something like maybe a user struct. So I call this struct user. Maybe I want to derive hash derive copy drop. So if I have this one and I have maybe say a user has a file 252 as their name, and maybe their ID is a contract address. Just a moment, address like this. Let me swap them. So you'll notice that contract address is not there and I need to import it. So the fastest way, sometimes that's why I said the autocomplete might not work, but best that you set it up to help you catch these errors. So I'll just do like that. Now I have a user struct, but now I want to use it within my storage. It's just this, maybe say users, and maybe the key is and in fact this is a legacy map. So I'll talk more about this, but just give me a moment to finish this. Is that and maybe user there. So you can do something like this. Okay, am I doing this one wrong? It should be like this. Oh, this should be like that. Yep. So you might be doing something like this, or this should be a comma, but let me just now implement the full functions there. So you can be doing something like this and expect the users to be stored into the storage struct. This might fail because if you want to store a custom data type that is not given by Cairo, and in fact not even files 252s, just the default ones, that's the integers, the bool, and integers, bool, and tuples. The rest you can't like sort of store them. You have to sort of implement for them. I think I'm not sure whether you can store file 252. I've not tried it, that one, but and arrays you cannot store them here. So if you want to store something into storage, like your custom struct, remember to decorate your struct with Starknet store like this to allow Starknet to be able to store your custom struct onto the smart contracts. Otherwise, it won't work. So this part of the things that I wanted to talk about before we get started in writing our first smart contract: Starknet store, Starknet interface for traits, and Starknet contracts to mark the main endpoint or the main contract, the storage macro to mark the main storage struct, the event macro to mark the main event enum, and the derive drop event to also mark an event that is like these structs. And also you can be able to see I'm using here keys. This is for sort of filtering there at StackScan or Voyager. So if you want to have a given key to be sort of indexed or be used in filtering, you can add it like this. Like this is a given key here. Then we have hash external v0 to mark all the functions in this maybe implementation to be public. That's how it goes. Maybe there are more and more of these macros will be adding, but these are the most common. But critically remember, something like this, the Starknet events, I realized that they can only run when they are set under the hello or under the your contract. Otherwise, if you sort of try to move these events out of the contract itself, they will fail to work. So just keep your stuff here. That's your events and storage under the main contract. Then also the implementation, remember to do them there. But the rest of the stuff that are not here, you can safely move them outwards to a different file. And something we can do here to quickly help us through, for example, this user here might not be found at some point. So to avoid such errors, and we have contract address here, and we have imported also contract outside there. So these are the two different modules. Mod Hello Starknet does not have the outer scope. So you need to pull in some stuff from the outer scope. How do you pull them? You can use something like maybe super. Then I can pull the contract address, pull the user, maybe even hello Starknet, like that. I can pull all of those from the outer scope easily and use them within my module, that's hello Starknet. And finally, we are going to look into tests. And in this case, tests are written using the Starknet SNForge standard library that we saw under scarp.toml file. So that's why I said there are two ways of writing your test. You can either use the test suite case given by Starknet, or use SNForge. So SNForge is very critical in this case. That is, it will help us quickly come up with the complex test stuff. So that's how tests are written. Deploy contract, it will deploy a contract, return a contract address, and use a dispatcher to quickly interact with your contract. Safe dispatcher .get balance, .increase balance, and all those stuff. And another thing you need to take care of is the versions that we have here. You can be able to see here we have a SNForge standard tag 0.10.1 and Starknet 2.3.0. Remember, all those versions must match what you have installed. So remember to run scab maybe dash dash version. I have scab 2.30, I have Cairo 2.30, and I have 1.30 of Sierra. So I have to use the current version that I've installed in my local machine of scab, there for Starknet. The next part is Starknet Forge. If I try to change the versions, so I have to make sure that SNForge, the current version I have for SNForge is the same version that I have for my dependency here, SNForge standard. Otherwise, you're going to be into problems. So remember that. I don't have much to say. I think I've tried to push out everything, and yeah, get ready for the next part, that is writing our smart contracts. Thank you for watching. Remember to like, share, subscribe, and also let others know about the good work our Starknet's doing by sharing this video. Thank you very much.